Our talk will be about how to classify news articles in the real world. My name is Malgorzata and I'm a machine learning engineer at Axel Springer AI, and I'll be holding this talk with Helena Peña, who's a data scientist at Upday. So it was a joint project of our two companies. And this is our agenda for the next 15 minutes. We're going to give you a really brief introduction to upday, and we're going to show you what way each article has to go through from the publisher to the end user of upday. And with this background knowledge, we'll be able to move on to our project, where we will show you the data, talk about its quality, and then move to the model search and the model that is in production right now. Helena?
Hello, let's present update. Do you hear me? Okay, good. You will see a video that shows you how the user sees update. Update is a news app, a news aggregator for Samsung phones. So here you see the user scrolling through news. The user sees a picture, the title, a short description, and if he wants, he can click on one of these news and will land at the publisher. Yeah, update has two parts, mainly in the application. So what you see now, the My News part are automatized news, personalized. So completely, the selection is completely automatized by algorithms. There is another part, the top news part, that is completely editorial. What we present today concerns actually this automatic part of update. Yeah, next, please. So what's the life of an article for update? We first start with an article that gets published. Can you please click, Gosha?
Mm-hmm.
Cool. So let's say Welt publishes an article, and in a short amount of time, we want to have it available for update. So what will happen? Article components like text and title and description and image will get extracted. Eventually, the article would land at a step of the pipeline that is the classifier. So this is the component that we will talk today about. The classifier will say, is the article about politics? Is it about food? Is it about theater, etc.? And at the end of the pipeline, you will see we have a templated way. So all articles get shaped into the same way, where we extracted all these components I mentioned, and especially interesting today, the category and the subcategory. So in this case, it was culture, literature. Yes. So what was our project about? So news classification existed since the beginning of update. It was needed for this automatic part. So we had a classifier that actually works well. It's based on Elasticsearch with some business rules applied on top. It is, though, a dependency from a third-party company, and it doesn't have a retraining pipeline. So we wanted a new classifier. We're working on that because, we want one that works at least as good as the one that we have, which is already good. But the new one should be based on a machine learning model that is transparent to us and of which we can control its quality, especially now also in update, since update is covering now since few times 36 target markets with like 25 languages. We need to scale up these classifiers to more languages and more target markets. So it was also important to find something that can go easily to production and reduce costs.
And already in the beginning of the project, we identified some challenges regarding this project. One was already described by Helena. So our classifier had to be integrated into a pretty complex and third-party owned pipeline. So it was an interesting aspect in terms of engineering. But we also found some challenges in the data itself. First of all, our training data is from 2016. So for a news classification problem, it's quite outdated. And we were concerned that the model trained on this old data will not generalize well on the data from 2020. Another aspect of the data was the evaluation dataset that was pretty small. It had only about 10 samples per category, which is not enough to properly assess the quality of predictions. But at the same time, this evaluation set is used in the current system and is our only common point with the current system. So if we wanted to compare our performance with the old classifier performance, we had to use this particular data set. For the first iteration, we decided to focus on two languages, English in the UK market and Polish. We chose English because it's an important market for upday. There are many users in the UK using the app, and there are also many articles going through the article pipeline every day. And we chose Polish because it's a more complex language. So we wanted to see if we can train a well-performing model for a bit more difficult language. And we both speak a bit of Polish, so we could use this advantage. And for those two languages, we had 10 and 12,000 data points to train, and we needed to predict over 80 categories. This is how our training data looked like. We had the category that we had to predict. And we also had the title, text, so the body of the article, and the URL plus the picture attached to the article. And during our first experiments and working on our baseline model, we identified another challenge that was a bit more concerning than the first ones I mentioned, namely the inconsistency in the labeling. In this table, you can see 3 articles about the opera, that is the form of theater. And the 2 first ones are coming from the training set, and the bottom one is coming from the evaluation set. And as you can see in the last column, they were labeled with different labels. So we believed it can be pretty confusing for our model, and we decided to dig a bit deeper. We generated feature importance charts that you can see. And as you can see, they are for those 2 labels I mentioned before. And we discovered that for classical music, so the evaluation set label, the word opera appearing in the title speaks against assigning this particular article to this category. Whereas for theater stage on the right side, you can see that it's one of the strongest signals for the model to classify it as theater stage. So it's quite confusing then to see for the model a different label. And we wanted to see how often it occurs that our model is not really wrong, but something is wrong with the dataset. And we performed a manual check of 45 samples from this evaluation set that were labeled as misclassified by our baseline model. And we discovered that only 42% of the from this mini set were because our model was wrong. And the other almost 60% were mislabeled because either the ground truth was assigned incorrectly or the content was ambiguous, which means that either our prediction or the ground truths were as likely to be correct.
So now let's look at our workflow for selecting the model. So we have mainly text data, or we chose to only work with text data. Let's say we did not use the image of the article to classify it. So text pre-processing was our first step. Gosha, could you click, please? Yeah. So there, we did basic data cleaning using regular expressions. And then we considered 3 types of embeddings, so bag of words, GF-IDF, and BERT embeddings. For the models, we had experiments with the models from the family from the linear family, so logistic, regression, passive-aggressive, SGD, SVC, and multinomial base. And as well, we tried nonlinear models. We tried the cut-boost classifier and the BERT model with a classification layer. So for the setup, we tune our pipeline using grid search and Bayesian optimization. So we decided to use grid search for a more extensive search of the TF-IDF parameters, and Bayesian optimization for the parameters of the linear models. And also we use it as a kind of feature selection to choose the best feature weights for our classifier. And finally, and very important choice, we had one metric we used to compare to the old model and among our new models, which is the weighted F1 score. So this is because of the imbalance that Gosha mentioned that we have in the data, and also because it's a metric that we have available for the old classifier, let's say. Something that accompanied us during the experiments was MLflow. MLflow is a tool for tracking your experiments, your code, your metrics, your model artifacts. And this was useful, let's say, to collaborate even as a little team, and also collaborate with yourself of 1 month ago when you want to rerun one model or check which implementation of your code generated certain metric. So this we recommend. In this overview, you can see the best performance per each model, ordered from top to bottom. In blue, you see the status of, let's say, the old classifier. On top, you see logistic regression. Logistic regression was for us since the beginning, setting a really good benchmark. And we managed to improve it by some points, and it still was not outperformed by other models. So same as logistic regression, okay, the passive-aggressive classifier, I mean, it was a bit faster to train, but okay, with the same score. BERT also managed to be better than the current classifier. There we say, I mean, we didn't invest so much work in BERT, we just fine-tuned it with our data, and like this out-of-the-box performance was tiny better than the current state, so we are in ongoing search if, okay, maybe we can improve it more with more work. CatBoost models didn't perform so well from the beginning for us. So there we tried like a default back and forth embeddings, and also our TF-IDF features. It didn't turn out so well. Same as for SVM and knife base. After we chose to go for a first test with the logistic regression, we needed to integrate it in our pipeline. So how we did it is, if you look at the bottom, the classifier component shows old and new classifier. This means when an article comes in now, it will get both labels. So this is happening now during our test phase. So that at the end, the article has two labels, the old category and the new category. In this case, both said cultural literature. Especially important for us was to see how does this news classifier work with news from today. So Gosha mentioned our training set was from 2016, so we really need to try it out today, or in this case, I'm showing results from news from March 20. So this was a manual check by our news content specialist. They relabeled 1,000 articles, and there we could assess like the quality. So you see the comparison, old classifier and new classifier. So the old classifier or the new classifier, let's say, performs as good as the old one, actually even a bit better. We also saw that for both of them, their performance dropped. So compared to the training with the old data. So this shows how your model can age because of the training data that you put there.
Okay, so let's move on to the learnings. It was pretty interesting to see that BERT didn't outperform simple linear models out of the box. I'm not saying it cannot. We're working on improving it to see how well it can do. But taken how popular BERT has been in the past months, we had very high expectations that were not met exactly yet. It was also quite interesting or important to define what is best model for us. And it was actually quite nice for us that the logistic regression performed so well, because it's much lighter than BERT or any deep learning model. And it was good to define it in the beginning that something like lightweight is important for us. It was also important to that the model can be trained on relatively little data. So not only the quality of prediction was contributing to the best model. We completed this first iteration in 30 days, having 2, sometimes 3 people working on the project. And this putting a model into production and completing the full circle of this productionalization wouldn't be possible if we didn't prioritize our tasks. So by this, we want to say that there are many other models we could have tried out, or we could have a bit further or deeper with some other models, but we decided to focus on models that from the first experiment, the first phase, looked promising to us. That was our approach. And like Elena already mentioned, we use MLflow, and this was very helpful in our work to track what our experiments, what we tried out, what still needs to be looked at. And it was a true learning for us, because we all were new to the tool. So we had to learn how to use it, how to design our experiments in a good manner. And by the end of this project, we definitely could say that we improved on this. And in future, we will probably all use it, and we will be better at it. And last but not least, we really appreciated close cooperation with the stakeholder. It was the content quality expert. It was a good learning, and it was very helpful in our work to regularly consult our progress and adjust the way we're heading to in our project with someone who eventually will use the product and benefit from it.